The bisection method is an iterative root finding algorithm that requires a continuous function, and we will use the divide and conquer strategy. The prerequisites are that the function must change signs between points A and B. The algorithm itself is finding the midpoint of A and B, and then we will narrow this interval based on the sign of the function c. In order to visualize this, on this graph we can pick points A and B on either side of where y equals 0. We can then find the midpoint, and we can keep on doing this. We can keep on iterating until the function c is very close to 0. This will allow us for a very close root approximation. As the approximation is not exact, there will be error bounds. Because the interval halves every iteration, we can derive an exact bound on the error and determine how many iterations we need. We start off with the original error bound, where n is the iteration number and epsilon is the error tolerance. We must multiply both sides by 2 with exponent n, and then we will divide both sides by epsilon. Then we can take natural logarithms of both sides, and then we can rearrange for our final formula. Using the values from the problem earlier, we can input that a equals 1 and b equals 2, and for a fixed error tolerance of 0.001, we get the number of iterations required to achieve that is 9.97. Another quick example is when we have a function on the interval 0, 1 with the required accuracy of 10 to the minus 4. We'll first start off with the final rearranged formula. We will then put our values for a and b, and also our value for epsilon. And then we can go ahead and work out our number of iterations required. The advantages of the bisection method include the fact that it is convergent with mild assumptions and error bounds can be found analytically. Disadvantages include slow convergence, especially if an initial guess is close to the root. It also fails when the function only touches the x-axis, such as with the function x squared.